For each of the following linear transformations T, find its standard matrix A and determine if T is one-to-one and or onto. So in part A, T goes from R2 to R2 such that T first reflects points over the vertical x2 axis and then reflects points through the line x1 equals x2. All right, so to find the standard matrix A, what I need to know what happens to 1, 0 and what happens to 0, 1. The results of these form the columns of the standard matrix. Okay, so what happens to 1, 0? I'm going to draw a little sketch. I'm going to follow 1, 0 through the description here. So first, T reflects the point over the vertical x2 axis, so it's going to land over here. And then it reflects the point through the line x1 equals x2, which is this line here. So it's going to reflect over that and land here. So T of 1, 0 ends up at 0, negative 1. Okay, T of 0, 1, 0, 1 is right here. And when I reflect over the vertical axis, it stays right where it is. And then you reflect over the line x1 equals x2, and it's going to land right here at 1, 0. So the standard matrix A is 0, negative 1, 1, 0. If you RREF this, you were going to end up with 1, 0, 0, 1, which has a pivot in every row and a pivot in every column, which means that this is one-to-one and onto. Okay, next problem. T goes from R2 to R2 such that T of x1, x2 equals x1, 0. So to find the standard matrix A, column 1 is T of 1, 0. Column 2 is T of 0, 1. T of 1, 0, just according to this rule right here, x1, x2 is x1, 0, so this is going to be 1, 0. And T of 0, 1 is going to be 0, 0. So the columns of my standard matrix A are 1, 0, and 0, 0. And is this one-to-one or onto? It is neither. There is only one pivot, so I do not have a pivot in every column, nor do I have a pivot in every row. So this is neither one-to-one nor onto. Okay, this time T goes from R2 to R such that T of x1, x2 equals x1. Okay, so column 1 of my standard matrix is T of 1, 0. Column 2 is T of 0, 1. So T of 1, 0 is 1, and T of 0, 1 is 0. So A is, column 1 is 1, column 2 is 0. And is this one-to-one or onto? So I have one pivot. So every row has a pivot because there's only one row, but every column does not. So every row has a pivot. That tells me that this is onto, and there is not a pivot in every column, which tells me that we are not one-to-one. Okay, T goes from R4 to R4 such that T of x1, x2, x3, x4 equals blah, 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 blah. Okay, so column 1 is going to be T of 1, 0, 0, 0. Column 2 of the standard matrix A is T of 0, 1, 0, 0. Column 3 is T of 0, 0, 0, 1. And column 4 is T of, oops, I missed, that should be a 1, then a 0, and then 0, 0, 0, 1. Okay, so T of 1, 0, 0, 0. Just going to plug into these formulas. So x1 plus 2x2, that's 1, 0. 2x2 plus x4 is 0, and x2 minus x4 is 0. 0, 1, 0, 0. So that's going to give me 2, 0, 1, 1. And then 0, 0, 0, 0. And 0, 0, 1, negative 1. So A is just each of these vectors written in a matrix. 1, 1, 2, 3 zeros, 2, 0, 1, 1, 0, 0, 0, 0, and 0, 0, 1, negative 1. Okay, so this is definitely not one-to-one nor onto, because I have a full row and a full column that don't that are all zeros. So this is not one-to-one nor onto.